Okay, so in this video, we're going to look at page 64, which is the next trig ratio that we're going to talk about, which is the trig ratio cosine. So when we're talking about cosine in our mnemonic device SOHCAHTOA, we're looking at the CAH part of that. And so when we're creating the ratio for cosine, we're still going to label the triangle in the exact same way that we did for tangent, meaning across from the right angle, we're going to label that as the hypotenuse of the triangle, that the side that is opposite theta, the same way that the hypotenuse is opposite the right angle, that's the opposite side, and that the other side, the one that's next to theta, is the adjacent side. And so for this one, our mnemonic is CAH. The C represents cosine. The shorten for cosine is COS, so the first three letters, just like it was for tangent. So cosine of theta is written as cos theta. And then adjacent is our A over our H, hypotenuse. So that means that cosine of theta is equal to the adjacent side divided by the hypotenuse. So today, when we're looking at triangles, we will know the adjacent and hypotenuse side and be able to find the cosine ratio. So just like we did with tangent, we're going to practice just creating that ratio using C equals A over H. So remember that on a right triangle, the first thing you want to label is the hypotenuse, because that's not always going to be the same side, no matter what the angle we're concerned with is. And so notice that we're finding cosine of A and cosine of B. So those two values will be different, and the adjacent and opposite for each of them will be different. So if I'm starting with A, I'm going to take A. If theta is here where A is, that means that the side opposite of A is 12. And so the side that's adjacent to A is that side of 5. So the side that's adjacent to A is 5. The side that's opposite A is 12, and the hypotenuse is 13. Cosine is equal to adjacent over hypotenuse. So that means we're going to put 5 over 13, and that is going to be cosine of A. Cosine of B is going to be the side that's adjacent to B over the hypotenuse. So if I look at where B is in my triangle, the side opposite of B, so that means the theta is here, the side opposite of B is that side 5, which also means that the side adjacent to B is 12. So cosine of B is the side adjacent to B, which is 12, divided by the hypotenuse, which is 13. Cosine of B is 12/13. Okay, so that is finding cosine adjacent over hypotenuse. So for this next page, we're going to be doing the same thing we just did, except that we have some radicals going on, so we are going to have to simplify. So those values weren't simplifiable. We weren't able to simplify them. So let's start again with identifying the hypotenuse of the right triangle. So K is the right angle. That means that this 24 radical 3 is the hypotenuse. So when I'm finding the trig ratios, that tells me that 24 over radical 3 is going to be the denominator for both of them. Hypotenuse is the only one that I know for sure is going to be the same no matter what. So when I'm doing the idea that C equals A over H, H never changes depending on the angle. And so that's going to be 24 radical 3 no matter what. I'm not sure I wrote 25 down there, so let me fix that. Maybe not. Here we go. 24 radical 3. Okay. So this first one is asking us to identify cosine of J. So J is here. That means that the side opposite of J is 36. So then that means that the side adjacent to J is 12 radical 3. Cosine is adjacent over hypotenuse. So for J then, we're going to put 12 radical 3 over 24 radical 3. So if I simplify this, the radical 3's reduce. And then if I think about 12 over 24, that reduces to 1/2. So cosine of J is 1/2 for this triangle. Now I just need to find the side that's adjacent to L. Excuse me. So if L is here, the side opposite of L is 12 radical 3. So the side opposite L, that's not what I need for my equation. I need the side that is adjacent to L. So that means that that's the 36. So the side that's adjacent to L is 36. This one's going to be a little bit more complicated because I don't have a radical to get rid of, and I'm not allowed to have a radical in a denominator. So when I'm writing this in simplest form, let's start by reducing. So 36 and 24 are also divisible by 12. So if I divide 36 by 12, that's 3. And if I divide 24 by 12, that's 2. So I get 3 over 2 radical 3. Remember that we are not allowed to have that radical 3 in the denominator, so we want to rationalize by multiplying by radical 3 over radical 3. And so our numerator then is 2 radical 3, and our denominator is 2 times, remember when I'm doing this, the whole point is that it turns into just a regular 3. So that becomes 2 times 3. I don't need to multiply that because notice that my 2's can reduce. So that means that this answer is radical 3 over 3 for cosine of L. Okay, so then the rest of this is going to follow just like we did with tangent, where we're going to solve for sides. We are not going to do an application problem, but then we will solve for angles. So when I'm solving for the sides, I'm going to start with organizing my work in terms of labeling the triangles for hypotenuse first. So if I look at my right angle, 7 is the hypotenuse. The side opposite of 62 is the blank side. So that tells me that I'm not going to use a trig ratio that has O in it anyway. And then the side that's next to the 62 degrees is the side labeled X. So again, notice that I have H labeled with a number and I want to know A. So this is a clue to when I get later and I know all 3 of the trig functions, that's how I know which one to use. This one, it's obvious that I'm using cosine because this is a page that's dedicated to cosine. So the fact that I know H and I want to know A, that's my clue that I'm going to use the cosine ratio. So I would do cosine of 62 degrees, and that's equal to A over H. So that's going to be equal to X over 7. And then I solve these the exact same way that we did with tangent. It's just that I'm going to be using the cosine button on my calculator instead of the tangent button. So I'm going to put cosine of 62 over 1. I'm going to multiply that times X. So 1X is just X. And then I'm going to multiply 7 times cosine of 62. Remember that I always put the number in front of the trig function. And then I'm going to calculate that value. So if I open Desmos, my scientific calculator, I'm typing in so that I have 7 times cosine of 62, and that gives us 3.28. So we're going to say that that's about 3.3. Okay, so X is about 3.3 for an estimate. So then for the next problem, we want to start the same way. Let's label across from the right angle is our hypotenuse. Across from the angle that we have measured in degrees, that's the side opposite. Again, notice it's not labeled, so that tells me I'm not going to use a trig function that involves O. And then I know the adjacent side is 27. So it switched which one I know and which one I don't know for this. So the process for solving is going to change, but the setup's the same. So I'm going to use cosine because I know A and I want to know H. And that's the trig function with those two letters in it. So I've got cosine of 24 degrees is equal to, A is 27 divided by h is x. So 27 over x is the ratio for cosine of 24. So this is going to allow us to solve for x. Just like we did in the last one, we want to put cosine of 24 over 1 so that we can cross multiply. We always want to start with the cross that will give us x. So if I multiply 127, that's not going to give me x. So I want to multiply x times cosine of 24. And then multiply 1 times 27 and put that on the right side. So then that gives me that is equal to 27. Since x is being multiplied by cosine of 24 to isolate x, I want to divide both sides by cosine of 24 degrees. So then x is equal to 27 over cosine of 24. And so if I open up Desmos and calculate that, so I'm doing 27 divided by cosine of 24. That gives us 29.55. So that's going to round up to 29.6. So this is about, oops, sorry. This is about 29.6. Okay, so the last thing that we're going to do with cosine in this video is to solve for the angle. So just like we talked about with tangent, I'm going to use an inverse trig function to solve for a missing angle. So the inverse of cosine is called inverse cosine. So it's written that cos -1. So this is inverse cosine when you read it, not cos -1. Or it's also arc cosine. Depending on what you remember, what you want to say, it is inverse cosine or arc cosine. Remember, since cosine is adjacent over hypotenuse, that means to find theta, when I know the adjacent side and the hypotenuse, I'm going to use inverse cosine to calculate that. So for this triangle, we're going to start with identifying the hypotenuse. I'm just going to do that for both of these here. So I have the right angle. That means this is my hypotenuse. For number 7, same thing. That means that 24 is my hypotenuse across from the right angle. The side opposite theta is the blank side on 6. Also the blank side on 7. So again, the way that we knew we were using cosine for all of these is that notice O was always blank. Last thing we're going to do is the adjacent side. So the side right next to theta is 44 for number 6. And the side right next to theta is 19 for 7. So instead of setting up with cosine of theta first, we're going to have theta is equal to the inverse cosine function of our ratio adjacent, so in this case 44, over hypotenuse, which is 52 for problem 6. So we are typing into our calculators the inverse cosine of 44 divided by 52, which gives us 32.2. So that means that theta is about 32.2 degrees. Sorry, I just want to double check I wrote that correctly. Okay, so then for the last one with cosine, what we're going to look at is the same type of problem. So we want to find theta. Theta is equal to the arc or inverse cosine of the ratio of the adjacent side over the hypotenuse. So the adjacent side for this triangle is 19. The hypotenuse of this triangle is 24. So if we go and calculate on our calculator that the inverse cosine of 19 divided by 24, we get 37 point, that 6 is going to round up to a 7. So theta is about 37.7 degrees. Okay, so that is page 64, looking at the cosine ratio. In the next video, we're going to talk about page 65, which is the final one sine, and then we'll go through on page 66 and look at how I know when to use which one when I'm given an entire triangle and a problem to solve for a lot more.